All right, so here are just a few more examples dividing monomial radical expressions. I just wanted to show you a few more examples because you might see some like this, and I didn't want you to get confused since you hadn't seen examples like this. But let's just jump right into it. So when we look at this first example, remember we wanted to rationalize the denominator. So in order to do that, we need to multiply it by something equal to 1. So I'm just going to multiply by the square root of 5 over the square root of 5. And here's why. I don't want to get rid of the entire denominator. That's not the point because I'm still dividing. So I do want to get rid of this radical. In order to do that, I have to multiply by this square root. So the square root in the denominator is what I'm multiplying by here. That's equal to 1. All right, so I'm going to have 2 square root of 3 times square root of 5 over 3, and then square root of 5 times square root of 5. It's going to be square root of 25, and we know the square root of 25 is just 5, right? So 3 times 5 is all that's left here. Sorry, I'm going out of focus for some reason. All right, so now I'm going to simplify this a little bit more. I'm going to keep multiplying. So remember, we multiply coefficients by coefficients, so that would just be a 1 there. So I have 2 times 1, and then square root of 3 times square root of 5 is square root of 15 over 3 times 5. It's going to give me 15. All right, and I look at 15. I have 1 times 15, and I have 3 times 5. None of those are perfect squares, so I don't have to simplify that any further. So that would be my final answer here. All right, so just to recap, I don't have to get rid of the whole denominator here, just the radical. So I'm multiplying by the radical over the radical to rationalize the denominator. All right, let's move on to this next example here. So I've got 10 over the square root of 8. So what am I going to multiply by? I'm going to multiply by square root of 8 over square root of 8 because that's just equal to 1, right? I'm not messing with the value of the whole problem. I'm just kind of manipulating it, moving some things around, right? Okay, so square root of 8 times square root of 8 is just 8. Hopefully we've kind of gotten a rhythm. We kind of understand why that is. So 10 times square root of 8 is just going to give me 10 square root of 8. All right, now I'm looking, can I simplify this radical here? So in other words, does 8 have any factors where 1's a perfect square? So I have 1 times 8. I have 2 times 4. Are any of these numbers perfect squares? Yes. 2 times 4 is going to work. All right, so I'll have 10 times the square root of 4 times 2, not 4 times 8. So 10 times the square root of 4 times 2, simplifying that radical, all over 8. All right, so now I pull the square root of 4 out, which is 2. So square root of 4 is 2. I pull that out, so I have 10 times 2, square root of whatever's left here, so 2, over 8. All right, so 10 times 2 is going to give me 20. Square root of 2 over 8. Now remember, I rationalized the denominator, or I got rid of the radical in the denominator. Then I simplified my radical. Now I need to check, can I reduce the fraction? So the coefficients here, can I reduce that? Yes, I can. They both have a 4 in common. So if I divided 20 by 4, I'm going to get 5. 8 by 4, I'm going to get 2. So I would have 5 square root of 2 over 2. All right. Let's look at this last example here. So remember, if it's written with a big radical, we can just rewrite it as square root of 6 over square root of 12. This will just make it easier to see what our denominator is as far as what we need to multiply by. So remember, we're multiplying by the radical in the denominator over itself, so square root of 12 over square root of 12. And when I multiply, that's going to give me square root of 12 times square root of 12 is just 12. And then square root of 6 times square root of 12 is going to give me square root of 72, because 6 times 12 is 72. All right, now, here's how I like to look at the numerator and simplify. I usually just look at the number here and think of its factors. So I'll think 1 times 72 gives me 72. And then I'll think 2 times 36 gives me 72. So I'm looking, are any of those a perfect square? I usually start with the smallest and go up, because up here is when you'll get your simplest terms here. So I'm going to use this one here, 2 times 36. So this can really be rewritten as the square root of 36 times 2 over 12.